Hello, my name is Danny Nowlan and I'm the Director of ChassisSim Technologies, and welcome to this latest episode of Dan's Vehicle Dynamics Corner. Ladies and gentlemen, we've got a real treat for you today. In the past, I've spoken about the ChassisSim's track replay feature, or what's sometimes referred to as the open loop simulation feature. Now, what we're going to be talking about today is how you can use that track replay or open loop simulation feature to actually do step steer and circle track testing using ChassisSim. And this is actually something that's really exciting, actually, because it's only really something that we've literally just gotten onto, and it was that useful. I figured, well, it'd be a fantastic topic for a tutorial. So this is what we're going to be discussing in this tutorial. So believe it or not, what you've actually got to do here for getting this, for making this happen, is actually incredibly simple. Okay, the first thing you've got to do is, as I might have discussed on previous tutorials, for the track replay what the track replay simulation needs, if we go into the track replay simulation section, is what it needs is it needs a monster file exported out at 10 Hertz. Now, for the uninitiated, the monster file is an ASCII tab delimited file that contains track distance, RPM, lateral G, longitudinal G, your forward damper displacements, steered angle at the tire. That's basically your input steer, but measured at the tire as opposed to the steering wheel. Throttle and speed. Once you've got those, you can pretty much run the track replay simulation. And with the adjustments that we've made to the track replay simulation, it effectively uses the speed and the steer inputs as a target to go. So how can we exploit this if we want to just do step steer inputs? Believe it or not, it's actually really, really easy. What I've got here is a monster file that's been configured to gear just that. So let's just open this up in Excel so you can have a look at what this does. Okay, so here's a monster file. So the key things to get right is that we need basically our track distance in meters, and we have our target vehicle speed in kilometers per hour. Now, what I've done here is I've just selected a target speed at 90 kilometers per hour. And what I've done is, since this is at 90 kilometers per hour, and I'm keeping this constant throughout the test, I need to export this at 10 Hertz, so 90k an hour, divide that by 3.6 is 25 meters per second. So as you can see, what I've done here is, because this is at 0.1 of a second, I'm doing this over a kilometer, so you can see that I've got 400 entries. So what I'll do is I'll typically type in 1000 here, I'll type in 0 up here, and I'll linearize between the two. So what I'll now do is I'll choose my RPM to match my constant gear. So in this particular example, I set it up at third gear. Now, the question you might ask is, that's fantastic, how did you sort that out? Real easy. What I did was that I loaded the card that I wanted to do the fixed steer input test on, which in this case was the Dallara F310 template in ChassisSim. And what I did was, okay, I knew my speed was 90k an hour. I clicked on the bell housing and I played with a couple of the gear ratios. So second is a torque ratio of 6.4, third is 5.09, and all I did was basically take the 90 kilometers per hour, converted that into what the rotational velocity is, divided that by the gear ratio, and from that I was able to deduce the RPM. So that pretty much formed that entry here. Now, the next thing to consider was what the throttle entry was. Now, in this case, with the throttle entry, look, don't get overly fussy about that. The only reason I say don't get overly fussy about that, in the track replay simulation, the forces that ChassisSim is going to apply is going to be determined by what the speeds are doing and what your AXs are doing. So again, it's more there just basically to represent the data, but the way I worked that out was I figured out the drag, I knew what the gear ratio was, and from that I was able to deduce what the required engine torque was going to be, and from the engine torque divided by that by the max engine torque, and from that I determined what my throttle ratio is. Now, here's the key. This is going to be, this column here is your steer column. Now, what I've done here is I'm just giving it a step steer input of 5 degrees. Now, so what I'll do is I basically entered this as an entry of level of 5 degrees, and basically linearize that down here. However, here's the real trick for young players. What you've got to do here is also make sure you put in an estimation for lateral acceleration now, and do this in G. Now, this actually doesn't have to be like 5,000% accurate. Quite to the contrary, because we're using this in a slightly different way. What we actually want to do is that we want to overestimate what we're doing with our what we want to do. We want to overestimate what our G is going to be, because part of the safety in the track replay simulation is if you've got a badly conditioned model, we use the lateral G as a measure to clip that, just in case the results start to go silly. So what you've got to do here is select the areas that you want at your fixed steer, linearize between these two, so you'll wind up with an end result like this. And then what you'll do here is make sure that you've got a G signal to correspond appropriately. So when you're done, you should have something that looks like this. So let me just highlight it here so you've got a really good picture. So here you've got your G signal and your steer signal. Now here, steer is going to be to the right, and here I'm going to select my AY as being positive. And I'll show you how to deal with that in ChassisSim in just a tick. So once you've got that, you save that, and you save it as an ASCII text tab delimited file. Now, here's where things can get. Here's where things get really. Here's where things get Here's where things get interesting. Now, what we need to do is we're going to need to make this work. We're going to need a curvature file and a bump profile. Now, you might think, oh my lord, we're going to have to make this up. What are we going to do? It's really simple. In the track replay simulation and the open loop simulation, the curvature and the bump profile, the curvature file is used in concert with the altitude camber file to reconstruct what the normal road inputs are doing. Because we're doing flat track testing, we don't need any of that. So what we need to do though is just to tell ChassisSim that we've actually got something in there. I'll just open that up with Excel, is that we take the distance vector from our monster file, we've pasted it in the second column here, and then we just put a whole bunch of zeros for the curvature. So you save that, and you save that as a track test track. And then for the monster file, or you've got for the bump profile, all you've got to do is actually, let me open that up in Excel, because that might be a lot easier to view that in Excel. So what we'll do here is that we'll take the distance vector from the monster file, and what we'll then do is then basically take those damper displacements that we had from the monster file, and what I did was I just basically put the damper displacements to 0. So forgive me for glossing over that. I basically put the damper displacements to 0 in the monster file, and I'm putting here as 0 for the test track bump profile, and that will simulate a perfectly smooth circuit. Now, if you wanted to get cute with this, one of the things that you could do is come up with, say, a random number generator in MATLAB and actually populate that out. But given that we're doing a smooth flat track approximation for testing purposes, we can leave that 0 for the time being. So, okay, so that's great. How are we going to set this all up in ChassisSim? Real easy. First things first, we're going to set up a data log for this. Now you can export this out to any of the data viewers that are supported in ChassisSim. That's Toolbox, Magneto Morelli, Motec, Bosch WinDarab, Atlas, AIM RoStudio analysis. So you can pretty much set up a data log, which I've done here. So I'm exporting the run, exporting it to Motec. Here is my car name, test track, and pretty much what I'm setting up for my comment. It can be pretty much anything that you want. and then obviously the log file that this is going to. Now, so what we'll do is we'll go into circuit data, we'll load in the curvature file, we'll load in the bump profile. Now, here's a trick. The first trick is make sure, click here to enable open loop drag strip mode, and that's pretty much just to keep ChassisSim on side because of the fact that we've just effectively put in a straight line. So that's more there for window dressing, but you still need to do it. So click here to enable open loop drag mode. Now, the other trap is because now the bump profile is at 10 Hertz. Go to bump profile modeling and select the damper sampling period to 0.1 of a second that corresponds to 10 Hertz. This will be probably the only time you'll ever change this, because all of the other times you're going to leave that sampling period of 0.02 in simulate bump profile modeling. So we'll leave that at 0.1 of a second. And then what we're going to do is we'll go to simulate tire force modeling advanced. Click here for the open loop simulation tab. So click here to run the open loop simulation. Number of laps to run, set that to 1. Target file, that can pretty much be any ASCII file that you want. I've just called this open loop sim data. Now, here's the key though. Click here to generate data log files in Pi, Bosch, Motec, or Morelli, and you've got to fill in the data logging options, which we've done. We navigate to the monster file that we've done, and we click on OK. Now, here's the key thing. Make sure that the sign of your lateral acceleration, sign of your steer, compares to what you've done in the monster file. What we've done here in our monster file, let me just go back to show you what that looked like. Open that up in Excel. What I've done here is I've got both steer and lateral G being positive for a right-hand turn. So it's absolutely imperative that here you make sure you've got that at 1 and 1. I'll just select 1 to that. And now let's run the sim. Click on OK. And now that's pretty much done our open loop simulation. And what we can do is we'll open that up in our data viewer of choice. And lo and behold, here's a step steer response. Let's zoom in to see what's going on here. So we've got a step steer response of 5 degrees. We can see what the dampers have done. We can see what the lateral G has done. And in this particular data viewer, I've got positive G being negative, and I've got positive steer being positive for a right-hand turn. So you can see what your yaw rate is doing. You can also see what your slip angle is doing. So here we've actually got a car that's a little bit oversteery. But the brilliant thing about this is that you can now go through and make setup changes in ChassisSim using it like the lap time simulation is. But this time around, all you're doing is going in to going into the track replay simulation and going here and pressing on OK, and you can use this in exactly the same way that you use the lap time simulation. Where this is absolutely screaming for, if you're an OEM watching this is a brilliant tool to investigate what the car's going to do with a step steer or with a chicane replay situation. If you're if you're involved in Formula SAE or Formula Student, this is a great little tool that you can put in a rough tire model, put in a setup, and give it a step steer response and start to get an idea of what it's actually doing. Or dare I say it, you can use this for flat track. You can use this for flat track simulation. So, and what I mean for circle track as a virtual circle track tester. So, there's a lot of ways that you can use this. So, look. What I'd encourage you to do is, if you're a member of the ChassisSim community, by all means, give this a run. If you're if you haven't started to use ChassisSim yet, go to our website, go to our online simulation, and try it out for yourself, and just see what an effective tool that can be. And I look forward to catching up with you in the next episode of Dan's Vehicle Dynamics Corner.